everyone, my name is Amanda Pfeiffer. I'm an education coordinator at the Canadian Light Source. This video is part of our series where we are interviewing various staff members from across the facility. Before we get started though, I just want to acknowledge that the Canadian Light Source, which is in Saskatoon, Saskatchewan, is located on Treaty 6 land in the traditional territories of the Nehiyawak, Anishinaabe, Lakota, Dakota, and Yokota nations, and the homeland of the Métis. Part of our role as educators and part of the education team at the CLS is we are hoping to initiate relationships with various Indigenous communities and start working on a pathway where we are respecting Indigenous ways of knowing, moving forward in a spirit of partnership, reconciliation, and collaboration. So I'm here with Daniela. I'm going to get you to introduce yourself, tell us your job title and what you do at the facility.
Hi, I'm Daniela Broten. I am an electrical engineer, and at the facility I help beamline scientists and physicists to conduct their research by helping with electrical equipment.
Cool. So can you describe what is a typical day of work for you, whether it's when you're at the facility or even working from home as we are in these pandemic times?
My typical day is in an office environment. As you could see, that's why I could work from home. It's working on a laptop, and from there I pretty much oversee projects over some of high complexity, providing engineering leadership within a project team. I prepare project plans, like schedules, when will the work be done, cost estimates on how much it would cost, and creating a comprehensive work. I also develop concepts to meet given functional requirements and provides like creative engineering solution to problems without creating too many other problems because of a result of the solution. Also, I participate in design reviews, ensuring that the design quality, the technical accuracy is conforming to CLS standards and other relevant codes, like the National Building Code or the fire codes. Also, I prepare written documentation such as specifications or procedures, and often I do reports. Most of the day I review drawings and I guide on how those drawings are being designed. Once that happens, then we proceed with installation. So coordinating and collaborating with other departments and also with external vendors or contractors to complete those assigned projects and tasks. I also participate in review of procurement of tender results and recommend of which contract awards for technical systems, and act as a facility specialist for assigned systems such as fire detection and alarm systems, machine protection system, which would be like programmable logic controllers, or low conductivity water flow instrumentation, or heating, ventilation, and air conditioning, or power distribution, which is mostly the thing that I've been trained on.
Interesting. I guess one misconception I had was you never think how much detail and writing there is in engineering positions, and just what you shared, that sounds like there's a lot of that work involved in that. So I guess the question for you is, does your field, or thinking about like high school and what you learned, what kind of classes did you take that kind of relate to what the work you're doing right now?
It basically just touched on one of them. So yeah, report writing and documentation is important. So even though it's an engineering based on math and science, which are the predominant subjects that you would take in high school that are directly related to engineering. Also, the written communication skills are quite important, and I think that's what it helps. Also, working in a team, like the social aspect, working in a team or a group on an assignment, it's pretty much what we do on a daily basis. You can't really work in isolation, so delegating and completing tasks which impact the team, you also learn that from high school, which is kind of great because it helps you build on it. Also, team time management to meet deadlines, like when you have assignments that are due. It's also important to meet those deadlines, and you learn that quite early. Lab experiments are also similar to the test we do to check if an idea works in practice. So yeah, I find that those things, they started to be planted in high school and developed over the years, for sure.
Yeah, that's a really good point to share, because a lot of it in high school, you think about the content, but it's also you're developing your soft skills, like you said, the time management and the report writing and things like that.
Yes.
So next question. So what was your education path from high school to working at the CLS?
Well, I was good at math and enjoyed learning and science while in high school. And my parents came from trades where there were hands-on approach was required, like a mechanic and a seamstress. So I started in arts and science college, and after a 4-year degree, I was interested in studying engineering because I liked the math and the science part of it. So it was my interest. Also, in engineering, I had the option of going civil, chemical, structural, or mechanical engineering, and but understanding the concepts in electrical engineering encouraged me to pursue it. After working in consulting and manufacturing after graduation from engineering, I am excited to be part of the world of research and assist scientists in their quest for specialized knowledge, which they do at CLS. So it makes me feel like I'm being a small part in the bigger plan. So yeah, that's what encouraged me to go this path.
Interesting. So thinking more kind of about your field of work, is there any health or safety concerns that you have to deal with?
Well, the hazards are there whether I am working in this particular field or another field. It's pretty much for electrical. We pass some days we pass a transformer that is sitting just out there. It's not any different than a transformer inside our building or at the CLS building. Radiation hazards, for example, if you're too long in the sun, you're already at a similar risk as working at CLS, or traveling in an airplane. I know nowadays it's less of travel, but yeah, the radiation levels are there present. So you just have to be aware of them, and there are definitely safety mitigations that we have in place to address to a lower level. That way it's safe for us to work.
Yeah, I know in a lot of times when we're connecting with students, we always say safety is the top priority at CLS. There's so many different procedures and things in place and in order for us to work. So it's good to touch base on them and, like you said, to be aware.
Yeah, often it's not necessarily only mitigated by administrative procedures. It's also by design, and I guess as an engineer, it's exciting to be in that area where you could implement something to protect people. So things like our ACES system is definitely a personnel protection system. So
yeah, that's interesting. Kind of a similar question. You talk a lot about the various projects and kind of things that you have going on, whether you're working from home or at the facility. So do you find, is your field of work stressful, and how do you cope with it professionally or personally?
At times it could get stressful, but it's a good type of stress, just like the type that motivates you to get projects done. You have a deadline, that type of stress. Once achieved, obviously it's very personally rewarding. um, Family, health, and work balance is the key to coping. So things like walking at lunch on the U of S campus, or uh, going again, walking by the river. It's such a beautiful sight here where we have it, that it's very much for me a coping mechanism. And the social aspect. I mean, being in a group of people at work that you could relate to and talk to, it also helps with managing that stress and just making friends. Yeah.
Yeah, definitely. Um, yeah, so I know in my travels, even when I was in undergrad, I had a lot of friends that went into the engineering pathway, and they were very interested in it. And so I was wondering if you could perhaps talk about more about kind of how much money does that career kind of provide, or is there room to grow professionally?
Um, yes, engineering right now is on demand, and the forecast is even more so. So the pay is it's parallels that, and the salary survey from APEX, for example, indicates on the Association of Professional Engineers and Geoscientists that the salary ranges for a new engineer starting like next year, graduated, is $54,000, and then that range kind of expands towards the years of experience, the field that you work in, to about 247,000. So it's a good career. It's just up to you where you want to be at, whether pay is the most important to you, or lifestyle, or other things that would um, dictate where that price or pay is. Yeah.
Yeah. So kind of building off of that, I know you mentioned that it is in demand engineers. Um, so do you think you could share, like, where do you see the field going in the future? Like you mentioned how they are in demand. Can you elaborate on that a bit more?
Sure. There are over 250,000 engineers employed in Canada. So that's a lot of engineers. And there's an estimate that there will be quite a few retiring pretty soon. And with engineers per year going through the engineering program of about 12,000 graduating every year, there simply not enough that will be replacing the retiring engineers. So that's why I was mentioning that it's engineering is more of an on-demand job. So electrical engineers, as far as um, the type of jobs that they do, they're concerned with development and design manufacturing of electronics and any systems that we use that transfer electricity, right? So this means that whenever it involves power, it involves an electrical engineer. So in specific to that, things like computers, phones, smartphones, appliances, all of those things are part of our everyday life. So I expect that including designing power systems and grids, medical devices, robotic or automated systems, and radar. I worked in fiber optic manufacturing, and these are some of the technologies that we already have in place. And as you can imagine, the electrical engineers are in intense demand, and they're second to civil engineers, which are building so many structures in our world. So yeah, I could forecast that based on the information that we know, that yeah, engineering will be on demand.
Yeah, that's interesting how you shared about the different kind of not avenues, I guess, but when you think about electrical engineering, like there's so many different things that you can apply your knowledge to and have it can be involved in. So yeah, it'll be interesting to see kind of the future and how how the new workforce takes to some of the tasks that they are going to be handed.
Yeah, there's some of the largest employers of electrical and electronics engineering, for example, they start mostly in engineering services like low voltage power to consumers, that type of project. The next group would be the telecommunications side. So anything related to fiber optic, data transmission, all of that is takes about almost 20% of our engineers that are electrical. And then surprisingly, the federal government employs a lot of engineers. That's about 13 to 15%. There are estimates out there for that. And then there's, of course, as you pass now a lot of the distribution of electrical is underground, moved to underground, but you could still see the power transmission poles, and so that employs about 10% of engineers, which would be electrical power generation, transmission, and distribution between cities and power plants. Then there is the controls and instrumentation manufacturing. They're less than 10%, and further down is the research and development. So though that includes like the engineers that would be hired by CLS, but also the engineers that are actually working on developing new equipment, and so strictly research. And then there's the semiconductor and electronic components manufacturing, which has one of the lower level of employees, the lowest level of employees that are engineers, so electrical engineers.
I did not know that, especially about the government hiring a lot of the electrical engineers, but I guess that makes sense. Mm-hmm. So thinking now kind of about what you wish you knew before you entered the field, what would you, like to have known?
Well, it's good to know yourself. That's the best thing, because once you know your interests, like lists of what you know already that you like and can be applied to a career, or if you do a career assessment, like in high school, we used to have these aptitude tests, and that also listed, or for me, somewhere between engineering and restaurant owner and something in nursing. So I had quite an option as far as choices, but doing a career assessment test, that definitely helps in finding out what kind of skills you would like if you're good with people or with kids or with numbers, that would show up and that would guide you as far as career choices. And I think if I had a little bit more understanding before going into engineering of all of those skills, also the pay or the job availability. When I graduated, there wasn't a demand for engineers at the time. So it took a little while to get into the field, but yeah, working even in sales or even in doing AutoCAD to start with, it exposed and doing volunteer work that also exposed me to the options that are available there, and that kind of shaped the career path as well. And of course, the attitude. If you thrive for high stress, or you like to be in a leadership role or self-motivated, those all impact how I would have picked the career that I'm in. So, yeah.
Yeah, it's really important. I know as a teacher, you hand out those career aptitude tests and it's like, oh, we have to do another one. But, you know, if students really reflect on them, like gets you thinking about your career. And I really like what you just said there too, about just reflecting on who you are and, you know, what motivates you, and if you're independent or you like working in different, more social atmospheres. It's important to kind of reflect on yourself. So.
Yeah, that's why I think that this type of interview, it helps, because the more interviews you conduct with the people that could provide you that kind of information, it helps you decide whether you like that choice or not. Yeah.
Yep, absolutely. So kind of wrapping up, is there any words of advice that you have for students as they're considering their careers?
Choose engineering.
Yes, there's demand.
Yes, electrical engineering. No, on a more serious note, engineering gives you the option of doing projects all the way to going to the moon, to your everyday device that you hold in your hand. So the options are pretty much limitless. Again, if you know yourself and what you like, I think that has the biggest impact long term. If you're forcing yourself to be in a place where it's not really suited for you, eventually you will find your path. So the point is to start. You have to start somewhere that gives you the options to explore other avenues. So yeah, having the education is quite important. When I first started, it was more of a one bachelor degree is great, or the trades is great to just have one degree. Now you have people doing multiple degrees, or they go from master's to PhD. So yes, just be open to where the path takes you.
Awesome. Well, I think it's good. We'll kind of end on that note. So thank you so much for taking the time out of your day and sharing your perspective and sharing the engineering perspective. Like you said, there's definitely lots of different avenues and different roles that they play, both even at our facility and just kind of in our day-to-day lives. So thank you for sharing that.
Thank you, Amanda.